Hi, welcome to my video on solve trigonometric equations, quadratics part 5. And this video is on quadratics as a trinomials, factoring trinomials and solving equations that have trinomials. Factor each trinomial. Let's do a bit of practice first. Examples: sine squared theta plus sine theta minus 2. So if I call sine y, then I would have sine is y, so y squared plus y minus 2. And to factor this as a trinomial, there's no GCF, so we would use a double brackets. And to have a y squared is a y times y. To have the factors of 2, we need 2 and 1. And notice the product is negative 2, the sum is plus 1. So we have a plus 2 minus 1. So y times y is y squared, and 2 times negative 1 is negative 2, and the outside is negative 1y, inside is 2y, which gives us this trinomial. So we're factoring these the same, only we have, instead of y's or x's, we have sine thetas. So we do a double bracket. And note also that a is 1 in this, and when a is 1, the product is automatically on the end because of the product is a times c, and a is 1, c is negative 2, so the product is negative 2 when a is 1. So it's easy to factor these trinomials when you have a 1 in front of the leading term. So we have sine theta, sine theta, sine times sine is sine squared. Factors of 2 are 2 and 1. And again, the product is negative 2. The sum is a plus 1. So we need plus 2 minus 1. Multiply. 2 times negative 1 is negative 2. Add 1. And that's the factorization. Again, we have a 1. This one is easy to factor. So cos, we use double brackets. Cos squared is cos theta times cos theta. The factors of 1 are 1 and 1. 1 times 1 gives you 1. The sum is negative 2. Notice the product is plus, positive, and the sum is negative. So that must be a negative 1 and a negative 1. Multiply these two. Negative 1 is 1. Add negative 2. And again, we did the FOIL. First, outside, inside last, you would come up with this trinomial. Now this one's a little bit different because we have a is 2 this time. So we write down 2x squared plus 3x plus 1. If you let cos theta be x, then you have a trinomial that has, notice the a this time is a 2. There's no GCF. Remember, the product is a times c. So there's a, there's b, and there's c. So the product is 2 times 1, which is 2. And the sum is your b, so the sum is 3. So what factors multiply to give you 2? And that's only 2 factors of 2, so it's 2 times 1. And 2 times 1 multiplies to give you 2 and adds to give you 3. So that means that the 2 and the 1 is placed in the middle by 2x plus 1x plus 1. Because we're replacing 3x with 2x plus 1x, we can now have 4 terms, and we take out the GCF in each pair. So on the first two, 2x is common, so we remove it. 2x squared divided by 2x is x. 2x divided by 2x is plus 1. The GCF right here is a plus 1. So we take 1 out, we get an x plus 1. And notice that x plus 1 is common to this expression right here and this one. So we take it out, and we take x plus 1 out, we get a 2x. We take x plus 1 out of this, and we get a plus 1. So that's the factorization. So that's the same here. Because we have a 2, then again, go through all this. We have a product is a times c, and a is 2, c is 1, so the product is 2, and the sum is b, and the sum is 3. So the factors are 2 times 1. So we get 2 cos squared theta. We got a 2 and a 1, so it's a plus 2 cos theta plus 1 cos theta plus 1. So instead of having the x's, we have cos thetas. So we got 2 times 1 is the product of 2 and the sum of 3. 2 times 1 gives you 2 when you multiply it. 2 plus 1 gives you 3. So those two factors are going here and here with cos thetas. In the first two, I see 2 cos theta common. 2 cos squared theta divided by 2 cos theta is cos theta. And 2 cos theta divided by 2 cos theta is plus 1. And in the next two, we take out a plus 1, that's common. So that's cos theta plus 1. And again, cos theta plus 1 is common. And 2 cos theta. So cos theta plus 1 is here and here, so we take it out. When we do, we get 2 cos theta here, and we get plus 1 right here. And again, very similar to if you had cos theta, sine thetas, x's and y's, we're doing the same idea. And again, more practice in the factoring. Now we have a 3 and a 2. Notice this time we have the product is A times C. Remember, that's A, that's B, and that's C. So the product A is 3. C is 2. So the product is 7. The sum is the B. So the B is negative 7. So the factors, the only factors of 7 are 7 times 1. But the product is positive and the sum is negative. That means we must have 2 negatives. Multiply. Multiply these two, you'll get 7. Add these two, and you get, no, look what I said. Product is, no, isn't that something how the product is 6 and the sum is negative 7. So the product is 6 to get the 7. Sum is 6 and 7. So it's a 6 and 1. Or we could have 3 and 2. But the 6 and 1 will multiply to give you positive 6 and add to give you negative 7. 3 and 2, no matter what we do, will multiply to give you 6, but it won't give you a 7. So 3 and 2 won't work. So we have a 3. Sorry about that. I multiplied. Again, just be careful. The product of 3 and 2 is 6. Now, you know, after all this practice, why would I make that mistake? But just one of the things that happens to me. So I'm using negative 6 sine theta. And I have a negative 1 sine theta plus 2. So I figured out the two factors were negative 6 and negative 1, not 3 and 2. So I took the two factors and moved them here with a sine theta, negative 6, sine theta, negative 1, sine theta. Now I'll factor by grouping. So I'll take out a 3 sine theta in the first two. 3 sine squared theta divided by 3 sine is sine theta. And 6 sine theta divided by 3 sine theta is negative 2. And I see a negative here, so I take a negative. There's no GCF, always a 1 though. So negative sine theta divided by negative 1 is sine theta. And a positive 2 divided by negative 1 is negative 2. Notice that this binomial here and here are the same. So sine theta minus 2 is common. So what's left? 3 sine theta minus 1. And if you did the FOIL on this, just try to FOIL for a second, just to show you. If you multiply sine theta by 3 sine theta, you get 3 sine squared theta. Multiply sine theta by negative 1, you get a negative sine theta. That's the first right here. Outside is here. Inside is the negative 6 sine theta. And this is last. is a plus 2, so you add them up. 3 sine squared theta minus 7 sine theta plus 2. So to show you that doing the FOIL on these two binomials will give you this trinomial here. And again, when A is not 1, you have to do a little bit more work, like product and sum, to pick up the two factors and put them in the middle. Or you can do it from scratch and take a guess. 3 sine squared is made up of sine times 3 sine. Factors of 2 are 2 and 1. Product is positive, sum is negative, so we've got to be 2 negatives. So you have to put these down correctly. So if you didn't want to go through all of this, you could take chances and fill in what these are and make sure you check the FOIL. Okay, now that we know, practice the factoring on the trinomials, and that's done in previous unit in Algebra 1, factoring 2. I'm reviewing factoring 1 and factoring 2 now when we did the polynomials. So let's solve some. Solve for theta, 0 is less than or equal to theta less than 360, and check. So this time I'm going to solve and check to see if our answers are right. So we have cos squared plus cos minus 2, no GCF, and there's a 1 here, so this is easy to do if you think about it, double brackets. Cos squared is cos theta times cos theta. Factors of 2 are 2 and 1, and we multiply. Product is negative 2, sum is 1, so it has to be positive 2 minus 1 equals 0. So check. Cos squared, 2 times negative 1 is negative 2. Outside is negative 1. Inside is 2. 2 and 1, perfect. So now we have two factors. So we let each of those factors equal to 0. Oop, I forgot to put my theta in there. There's the two factors, and we solve for cos theta, negative 2. Solve for cos theta, and we get a 1. And notice that cos is negative 2, and that means right here there's no solution for this one. The reason? Because cos, the domain for cos or sine is negative 1 is less than or equal to cos theta is less than or equal to 1. Remember, the cos graph is going from 1 to a negative 1, 0. Cos graph is 0. 90 is 0. 180 is negative 1. 270 and 360. So it goes, if that's 90, that's 180, 270, 360. Then the cos graph, cos of 0 is 1. 90 is 0. Cos of 180 is negative 1. Cos of 270 is 0. So it goes, the cos graph is like this. And the cos graph is C, so it's a sideways sideways C. So a cos graph is a sideways C. Notice the C. So if I turn it around like this, you see it's a sideways C. Put that back in the correct position again now. Here we go. We have it. Now, guess why there's no solution? And if you did your calculator, right here, you did your calculator, cos is, theta is cos to the negative 1 up to negative 2, and the calculator will give you an error. It's telling you you can't have it. So where's cos 1? So we have the circle. This is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Cos is associated with the x, or is the x on a unit circle. So cos is 1, that's right there. So theta is equal to 0. Notice we can't have 360. 360 is also true, or negative 360 is also true, but we can't have it. We can only have from 0 to 360, not including 360. So the answer to this one is 0. Now we have to check it. So check. So I'll write down the equation. Cos squared theta plus cos theta minus 2 equals 0. So we're going to check that theta is equal to 0 degrees. So the cos of 0 degrees, and we put the square like this. The square is in here, but it can also be put there. And this is the cos of 0 minus 2 equals 0. And again, according to cos of 0, there's 0 degrees right here. The cos is 1. So it's 1 squared. The cos of 0 degrees is 1. 1 squared is 1. Plus 1 minus 2. So that's 2 minus 2, 0 equals 0. True. So that means that that's the only answer to this question. So checked it. Now let's work out another one. Okay, here we go. Solve for theta, but this time 0 is less than or equal to theta is less than 2 pi. Just then we had degrees. Now we have, because we have 2 pi is a radian. So we have to get the answers in terms of a radian. So what I do, I figure out the answers in terms of a degree, and then I work them out and change the degrees to radian. So we have to make sure that this is a quadratic because we got x squared. So we have to solve, make the equation equal to 0. Now, if you want to factor this quickly, because these numbers, remember that's a 2 there, so you got to be careful. So let's do it a little bit fast. There's no GCF, we have double brackets. How do you get 2 sine theta? Well, 2 sine theta comes from 2 sine theta times sine theta. That's easy. And the product is -1. So how do you get -1? Or how do you get 1? Is 1 times 1. So the product is negative and the sum is negative. So we have to put a plus and a minus in here somewhere to get the -1. So we put a plus here and a minus here. Then notice that the product of 1 times -1 is -1. And the sum, let's check, outside, that's a -2 sine theta. Inside is 1 theta. So -2 and 1, perfect. So we have the right factorization. Remember, there's a 2 here, so you got to be careful. There's no GCF. So we now go 2 sine theta plus 1 equals 0, or sine theta minus 1 equals 0. It's a quadratic, so there's two brackets, so there's 2 sets of answers coming out of here. So sine theta equals -1 divided by 2. Sine theta is -1/2. And we have right here sine theta equals 1. So we have a half, so we have to add sugar to coffee, and sine is positive in 1 and 2, so that means we have to get the answer in. We'll draw the circles, do the 2 of them down here. So we got a negative in 3, terminal arm is in 3, and notice I draw separate diagrams to make sure I'm not mixing everything up. We're in quadrants 3 and 4. So the terminal arm is in quadrant 3, perpendicular to the x-axis. Terminal arm is in quadrant 4, perpendicular to the x-axis. Sine is -1/2, and the sine is the y. So in this diagram, I got to put the y and -1/2. I got to put the y and -1/2. This is the x, this is the y. Hypotenuse is 1, hypotenuse is 1. And because we have a half, that means that this angle opposite the half is 30. That means this angle is 60. And this other side here is √3/2, but it's negative. And this right here is a -1/2. So because it's a half, then this angle is 30. This angle is going to be 60. That's a root 3 over 2, but it's positive on this side. So we have a reference angle of 30 degrees. So this is in quadrant 3. Quadrant 3 theta is 180 plus the reference angle. So that's 210 degrees. And in quadrant 4, we have 360 minus the reference angle, which is 30. So it's a 330 degree angle. And we want to get sine is -1, again on the circle. Sine is the y, sine is 1. So sine y is 1, so that's x is 0, y is 1 right there. So that means theta is 90 degrees. But we want it in terms of radians. So a radiant is 90. We multiply by pi over 180 to convert degrees to radians. 90 once, 90 twice. So we get pi over 2. 180 divided by 2 is 90. So 90 is a pi over 2. We got 210 degrees. So 210 degrees multiplied by pi over 180. But before we do this, I want to look at what 30 is. 30 is really, as a radian, 30 is 180 divided by 6. So again, 30 multiplied by pi over 180. Just think about it. 30 goes once, 30 goes 6. So 30 is equivalent to 30 degrees is pi over 6. And 180 divided by 6 is 30. Well, why I did that? Because what will happen is that when I'm finished here, because the reference angle is a pi over 6, this answer here will have a pi over 6, guaranteed. And this one right here will have a pi over 6, guaranteed. And let's just check. 210 divided by 180, divide by 10, you get the zeros gone. 3 into 21 goes 7. 3 into 18 goes 6. So that becomes 7 pi over 6. Because the reference angle is 30, which is pi over 6, all the answers will have a pi over 6. So how many 30s are in 210? 7 of them. How many 30s? Well, let's do 330 now, converted, just to make sure. Times pi over 180 degrees. Again, we got divide by 10, so the zeros cancel. 3 into 18 goes 6. 3 into 33 goes 11. So that's 11 pi over 6. And again, pi over 6 is 30. 30 times 11 is 330. So the answers in terms of radians, the smallest one, the 90 is the smallest angle, so 90 is a pi over 2. The next angle is 210, so that's 7 pi over 6. And the next angle is 330, and that's 11 pi over 6. So there's all the answers in terms of radians. And as you can see, this is a nice idea to do. You know, I mean, you think about 30 degree reference angle, which is pi over 6, so every radiant. So 30 into 210 is 7. 30 into 330 is 11. And another way to think about it too, if you got 60s, just watch this. 30, if you went around a circle and you have a 30 and a 30, and then you have another 30, you're all 30s. If you go around, you get all 30s. So there's your 30s, 30, 60, 90, 30, 60, 90. Notice there's 3 here, 3 here, there's 6, 9, there's 12 of them. So if you went as far as, like that's a 30, you went as far as 210. 210 is 180 plus 30, 1, 2, 3, 4, 5, 6, 7. So there's 7 30s to get to the 210. and they get way over here to 333. There's 12 of them all the way around, but we left off this 30, so there's 11 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just do a little bit of more explanation on that. Okay, and the last one to work out here. Find all possible values of theta in degrees. Notice this time we're finding all possible values in terms of a degree. So we have to simplify this equation. So we multiply sine theta times sine squared. Sine theta times 3 is 3 sine theta. And we're subtracting, so if you think about putting a 1 there, negative 1 times negative is a positive. Negative 1 times negative 3 is plus 3. So we have the brackets eliminated. Now we have to simplify. So sine squared theta, or we could have, I'll show you another way now. But let's go with this. So 3 sine add on 1 sine is 4 sine. Now, this is a quadratic because it got a square there. So there's a 1 here, so this is easy to do, double brackets. So sine squared is sine theta times sine theta. The factors of 3 is easy. 3 times 1 is 3 because that's the product, and the sum is 4. So the product is positive and the sum is positive. It must be 2 pluses. Again, multiply sine squared. Multiply 3 times 1, 3. Outside, 1 sine. Inside, 3 sine. 1 sine, 3 sine is 4. So it's 2 factors. Sine theta plus 3 equals 0. Or sine theta plus 1. Oh, we got that 1 we got the equal sign kind of high there. So that means sine theta equals negative 3 and sine theta equals negative 1. And again, sine, let's look at the sine graph this time. If I had to graph the sine graph, how would you graph it? Well, let's look at this circle here just for a second. Again, this is a 1, 0, 0, 1, negative 1, 0. Extremely important to have this totally memorized. The sine is the y. So at 0, 90, 180, 270, 360, and that's a 1, a negative 1. Sine begins with an S, so sine is an S. So the sine graph is a sideways S. Let me explain. So at 0 degrees, sine is 0. At 180 degrees, at 90 degrees, sine is 1. At 180 degrees, sine is 0. At 270 degrees, sine is negative 1. 270, negative 1. 360 all the way around, sine is the y, which is 0. So notice the sine graph is a sideways S starting at 0. Notice the maximum is, so the domain for sine is negative 1 less than or equal to sine theta less than or equal to 1. So the answer to this is no solution. Again, if you did your calculator, theta sine to the negative 1 on the negative 3, the answer would be an error on your calculator. But sine cannot be larger than 1 or smaller than negative 1. There's always 1, or negative 1, or in between. So that's why there's no solution here. And sine is the y is negative 1 right here. Y is 0, 1, 0, negative 1. So theta right here is 270 degrees. And it says you want all possible. So we have one answer, which is 270. But what happens with the sine graph is periodic. So the sine graph is periodic. That means it'll keep going up and down, down and up and down, like that. It'll keep on going, and it'll come back here, down, up, etc. Keeps on going, so it's periodic. And the period of the sine graph, the period is 360 degrees, or it could be 2 pi in radians. We want it in degrees, so this we add on 360 degrees, we times it by n, and we say n belongs to the integers. That's all of them. So right here we only worked out from 0 to 360. Now we got to add on the 360 because it keeps repeating. So if 270 is 1, this one over here would be add on 360, and we add on another 360. Or if we go backwards this way, you get back to here, take away, subtract 360, get negative 90. So some teachers will use, instead of 360n, some teachers or books will use 360k, where k belongs to the integers. So I use an n. N is for a number. Some books use a k. And that brings us to the end of factoring with trinomials. And again, if you like my video, click on the like button. If you're not a subscriber, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.